Okay, we'll start with reviewing domain and range question, and then we will go, we'll review the one in your note package, and then I'll switch it to look more like what you can expect to do on your exam. Okay, so for this domain and range of this function here, so if I said to you, what's the domain of this function? Remember what you do is you look and you say to yourself, what's the biggest x value? What's the smallest x value? If your graph goes to the end and there's no big points here, so like if this is not on your graph, what that means is that the graph is going to go forever. So it's going to go forever down, but that means also forever to the right. For set builder versus interval, not if it's a multiple choice question. Okay, so that's why I'm going to go through both. Okay, so if I said to you, what's the biggest x value that this graph would go to? Richmond, what would you say? What's the biggest x value? If it keeps going forever down and forever to the right. That would be the smallest x value, would be negative infinity, and the biggest x value would be infinity. Okay, so in set builder notation, what that would look like would be x is such that, and then you'd write x belongs to the element of the real numbers. That would be the domain. In interval notation is where you write the smallest number comma biggest number, and you could put infinities in interval notation. So in interval notation, it would be negative infinity comma infinity. And remember, infinity always gets rounded brackets. Now, if I was doing the range of this function does have a biggest y value. Edie, what's the biggest y value on this graph? 6. So that's the biggest. And Edie, what's the smallest y value? Negative infinity. Okay, so interval notation I find is the easiest for this one. What the range would be, the smallest is negative infinity. My graph goes to negative infinity, but my biggest y value is 6. 6 would get a square bracket, and infinity would get a rounded bracket. In set builder notation, what you have to decide is your graph, the y values on your graph, greater than or equal to 6, or is it less than or equal to 6? Maya, what would you say for that one? The graph is less than or equal to 6. So in set builder notation, what the range would be is y is such that y is less than or equal to 6, comma, y belongs to the element of real numbers, which means, again, y can be decimals within that range. Okay, what you need to know for domain and range is more going to be a question like, I want you to draw this graph. Okay, so x to negative 3 and y to negative 2 and draw an open circle. So at that point would be negative 3 comma negative 2. And then let's go x to 4 and y up to 5 and draw a closed circle there. I want you to do the domain and the range both in set builder and interval notation. And remember how I did that? I sort of always started by putting x in the center, and then I put the inequality signs, and I erased the equal to sign after. So sort of set it up like this. Does that make sense, Angelo? That point is 4 comma 5. Yep, 4 comma 5. Christian, what's your biggest x value? Would be 4. Do you want that this equal to stay or go? Stay. Smallest x value, Scarlett, would be what? -3 is my smallest x value. And you want the equal to sign to stay or to go? It would go. So I don't have an eraser, but what I would do is I would erase this equal to, because what the domain would read, it would be x is less than or equal to 4, greater than -3, not touching -3. Sophie, what's my biggest y value? 5. Do you want the equal to stay or go? Stay. And read, what's my smallest y value? -2 would be my smallest. Stay or go for the equal sign? Go. I'd erase that one. In interval notation, interval I find, again, even easier. It's always your smallest number, comma, biggest. So it would be -3, comma, 4. That would get your square bracket, and your rounded bracket would be for this one. That would be the domain of the function. What the range would be, it'd be rounded bracket, -2 to 5 square bracket. That would be your range. Okay, so you'll have for sure a domain and range question. Let's graph, and then we'll review continuous versus discrete data. So if we're graphing from a table of values, this would be my x, and that would be my y's, and we could get ordered pairs from here. So my first ordered pair would be 3, comma, 1. Then I'd have an ordered pair at 6, comma, 2, at 9, comma, 3, 12, comma, 4, and 15, comma, 5. So let's plot those 5 ordered pairs on my graph. 3, comma, 1, 6, comma, 2, 9, comma, 3, 12, comma, 4, and 15, comma, 5. Let's label our axes. So our x and our y, they are labeled, but it says that x is time in seconds and y is kilometers, distance in kilometers. So let's label time in seconds, and this will be distance in kilometers. Okay, you need to ask yourself if you're going to connect the coordinates, and how you're going to ask yourself, or what you're going to ask yourself, is, does time exist in between 3 seconds and 6 seconds? Does intermediate values exist? Izzy, what would you say? Yes. So I would connect those coordinates, and I would actually go down time to 0 seconds, because we're not going to have negative time. And if you're connecting, you could also extend past and put an arrowhead at the end. Now, remember, when we connect dots, was that discrete or continuous data? What was this data called? Continuous. So write down somewhere, connect dots is continuous data. When you wouldn't connect dots is you would look at your x-axis, and if you had, let's say, vehicles were listed here, okay, jumping from three vehicles to 6 vehicles, or 3 vehicles to 4 vehicles, you can't have half a vehicle. Or if I had movie tickets down here and price up here, you can't buy 1.5 movie tickets. That would be discrete data if you don't join the dots, okay? Now, you need, or you will get a question on independent and dependent variables. What would this be? Do you remember why? Is that dependent or independent? Christian? Dependent. So this is dependent variable, and the x is always your independent variable. Okay, so remember that. What I always, the one example that I always sort of like to think of that you could jot down is, in order to help remember which is dependent and which is independent, remember we talked about in class the amount of money that you earn, what does it depend on? Hours worked. So this would be hours worked, right? So you could work 0 hours. You could work 1 hour, 2 hours, 3 hours. Let's say you work 1 hour, you get $15. 2 hours, and you'll get 30. 3 hours and 45. I would connect the dots. This would be continuous data because there's intermediate values in between 1 and 2 hours. You'd have to get paid for working 1.5 hours or 1.6 hours, whatever you work, you'd have to get paid. And then remember, you always say what's happening here. So the amount of money you earn depends on, it always depends on your independent variable, the amount of hours worked. So this depends on this, okay? All right, function versus not a function. Jack, left graph or right graph? Which one is not the function? It will fail a test. Right is not a function. What test does it fail? Yes. The reason why this graph is not a function is it fails the vertical line test. Okay. When you draw a vertical line, if it intersects your graph at more than one point, it is not a function. So this graph, no matter where you draw a vertical line, it will only intersect your graph at one point. It's a function. What is key between what's a function or not is we're looking at the x coordinates. So here I would have a point at 3, 2. Here I'd have a point at 3, -2. You can't have an input of x and 2 different outputs. This would cause you to fail the vertical line test. So how you could see it without giving you a graph is I could give you something mapped like this. And I could say, is this a function or not a function? Jesse, what would the answer for this be? Not a function. The reason is it's going to fail here and fail here. So what's happening is we're going to have a coordinate at -8 going to 2, and -8 is being mapped to -2. If you plotted those points, here's -8, you'd have a point at 2, you'd have a point at -2. This would fail the vertical line test, right? If you draw a vertical line, it would go through that point and that point. So this guy, not a function. Okay, let's do number 18, but let's actually change it to a linear function. So in our course, we did line graphs, which were linear. So let's actually cancel or cross that out. And I'm actually just going to change it to the same one in 19. So write down f of x is equal to 4x minus 5. We're going to review how to punch this in our calculators. This is going to give us a line graph or a linear function because the degree is 1. So remember, all line graphs have a degree of 1. But what you would do is, in order to graph this, so take out your calculators, and where we graph is under y is equal to, clear what you have, and you're going to type in 4x minus 5. So x is right next to your alpha button, minus 5. Hit graph. If ever your graph window has been changed from a 10 by 10, you could always just reset it by hitting zoom 6. Okay, so zoom 6 will go back to a 10 by 10 window. Now, it's asking for 6 ordered pairs. What are 6 points on this graph? In order to get points off your graph, you'd go to your table of values. So second table. And let's just do 6 points on here. So I'm going to list -1, -9. That's an ordered pair. That's a point on this graph. So I'll list -1, -9. 0, -5 is another coordinate or ordered pair. 1, negative 1. And I'll do 2 comma 3 and 3 comma 7. Okay. If I gave you grid paper, which you'll have on your exam, if you're able to graph your function, you go to your table of values to get ordered pairs. You really only need 2 ordered pairs, and then you can connect those and extend your line, and you would have your graph. Okay, what is f of negative 9? Find it on your calculator. So you're already in your table of values. Find what f of negative 9 is equal to. Drew, what do you have as the answer? So let's see, f of negative 9, he said is negative 41, and he's correct. So f of negative 9 is equal to negative 41. What that is, it's a coordinate on your graph. When x is negative 9, the ordered pair would be negative 9. The y value is negative 41. Now, f of 132. I don't want you to scroll down to 132, okay? I'm going to show you 2 ways that you could get this. One of the ways is a 20-1 method, okay? So don't worry if you forget about this on your exam, because I'll show you the algebraic way. So you guys just go to your graph here. Hit second. If we hit trace, that's calculate. So second calculate. Type number 1 for value. You could type in any x value. Actually, I wonder if it will if it's off my graph. Let me just see. 132. No, it won't, because I've got to extend my window. Sorry, what I was going to show you, the negative 9 would work. If I went to second calculate a value, negative 9, it would give me that negative 41. But right now my window is only a 10 by 10 window. That's why it's not showing that 132. So I'll show you how we would get this one. We're going to algebraically calculate this. When x is 132, so take your x out. So write down 4 times 132 minus 5. And calculate what that answer would be. So 4 times 132 minus 5. 4 open bracket 132 minus 5. When x is 132, the y value will be will be 523. To get this guy, we would do the same thing. Take your x out, and we're going to input negative 2 over 5. So 4 negative 2 over 5 minus 5. 4 open bracket negative 2 divided by 5, and then minus 5. Negative 6.6. If it was a numeric, it would be decimal. If it was a fraction, like let's say it was a multiple choice, just math one fraction, that guy. Yeah. So I'm just going to write negative 6.6 though. Okay. Okay, let me review how we would find a y, given a y value, how we would find an x. So I'm just going to pick a number from here. Okay, write down this. F of x is equal to negative 25. If you see that, Tessa, what did I just give? That negative 25 is what? Is that x or is that y? That's the y value. What is the x value that would give a y value of negative 25? Now, I could see on my calculator that the answer is going to be negative 5, but let's solve it algebraically to make sure that you're good for that. Okay, so for the function, here was the equation. F of x is equal to 4x minus 5. We're going to take out f of x and put in the y value, because that f of x is just a fancy way of saying y. So negative 25 is 4x minus 5. I need to get this by itself. Read, what do you want me to do first? Add 5 to both sides. Negative 20 is equal to 4x. Angela, what do you want me to do from here? Divide by 4, divide by 4. X is equal to negative 20 divided by 4. Ruby is what? Negative 5, which I knew what it was from my table of values, but that's how you would get it algebraically. Okay. So right there, when y is negative 25, x is negative 5. You will have a question on x, y intercepts. So let's review x, y intercepts. We'll do the same function, okay? So just down here, if you have room, write that same function. Actually, I'll write it in using y. So y is equal to 4x minus 5. Okay, so x-intercept, these will always be algebraic questions, y-intercept. X-intercept, Kayla, what do you want me to do if I'm solving an x-intercept? That's right, let y equal 0. So you always first 4x minus 5, and then I'm going to take the y out, and I'm going to put in a 0. I'm going to box in that 4x because that's what I'm looking, I need to isolate that. Jack, what do you want me to do first? If I want to get that 4x by itself, add 5. We're going to get a decimal answer, that's okay. Richmond from here. Yeah, I want to get x by itself. Divide by 4. My x-intercept is 5 over 4. And I'm going to actually put that as a decimal, 1.25, or 1.3, I'll round to. So as an ordered pair, when x is 1.3, y is 0. Okay, my y-intercept, Ilana, what do you want me to do? Let x equal 0. So write your equation, box in your x, and put a 0. 4 times 0 is 0. Y-intercept is negative 5. So what that means is when x is 0, y is negative 5. You only need 2 points on your graph, if it's a linear graph, to get your actual graph. I could graph this, right? So in class, like I remember when we did our quiz for this, 0, negative 5 would be down here. 1.3 is a little bit harder, but where that would be, here's 1, here's 2, so I'll put 1.3 there. If I connect these two dots with a ruler and a straight line, that's what the graph would look like. And if I compare to this guy, my y-intercept is at negative 5, and my x-intercept is about 1.3. Okay? Um, We'll review up to parallel and perpendicular lines, pretty much this. Okay, find the slope of this using rise over run. What's the slope of this line using rise over run? So start here and figure out what the slope is. Sophie, what are you getting for slope? Yes. you're rising 4, and you're running 3. Now, I want you to confirm this slope using this formula. This formula will be on your formula sheet. y2 minus y1 over x2 minus x1. So for your 2 points, label 1 point x1, y1, 1 point x2, y2. Confirm that you're going to get a 4 over 3. So y2 minus y1 over x2 minus x1. 2 negatives will make a positive, and I'll get 4 over 3. Okay, so make sure you can count by rise over run. Make sure you can use your formula y2 minus y1 over x2 minus x1, which will be given. If I want you to draw a line parallel to this line, what will the slope of a parallel line be? So slope of a line parallel to this given line. It will be 4 over 3. If I want you to draw a line that's perpendicular, so there's your symbol for perpendicular, to this line, what would the slope of that line be? Negative 3 over 4. You would flip this, the reciprocal, and then if this one's positive, remember they were called negative inverses of one another, this guy would be negative. Okay? If I said to you, write the equation of this line in y is equal to mx plus b. You'll be given that formula. What would the equation of this line be in y is equal to mx plus b? Drew, what would you say? Sorry, what was the slope? Did you say? Yes. Y is equal to 4 over 3x minus 2. That's correct. Okay. You could write it over here because we won't do this guy. So you could use it over here. I want you to write this. Okay, so what do I want? I want you to write the equation in slope point form. But I want you to use this point here. Write the equation in slope point form of this line. This equation will be given, but I want you to use that point. Izzy, could you read me what your equation would be? Perfect. Because this would be, if that's your given point, that would be your x1, y1, and that would be your point. Now, you can be expected to get an equation like this. Where would they want you to go from here? General. So you will be given what the general form of the equation is. It's this guy. ax plus by plus c equals 0. This is the general form. Two things were necessary to go into general form. X must be positive, and we can't have something fractions. So I'm going to get rid of this divide by 3 first. That's the first thing I'm going to do. So what I'm going to do to get into general is I'm going to put my left side in a bracket and I'm going to put my right side in a bracket. I want to get rid of that divide by 3. So I'm going to multiply the left side by 3 and the right side by 3. How I'm getting rid of the fraction is over here, 3 over 3 will actually cancel because if I multiply this number in, it will give me 12 over 3. And 12 over 3 is 4. So the 3 over 3 will cancel. What I get to distribute in is just the 4. And I've got to put the 3 in over here. So what that would give me is it would give me 3y minus 6 is equal to, the 4 gets put in, 4x minus 12. Going into general, I'm first going to get rid of this negative 6. I'm going to see what my constant term will be. So I'm going to add 6 to both sides. I always like getting rid of that first. So add 6, add 6. And that will take me to 3y is equal to 4x minus 6. I could, from this point, go into y is equal to mx plus b. I could divide by 3, divide by 3, divide by 3. And I'd have that equation that I think it was Izzy told me. I forget who told me the equation. But I want to go into general, so I need to decide, do I keep the 3y and everything goes to the left, or do I move the 3y and everything goes to the right? Jesse, what would you do? Yes, that's right. So let's move that 3y. Let's subtract 3y, subtract 3y. In general form, the equation would be 0 is equal to 4x minus 3y minus 6. Okay, so I'm going to give you some practice for this. And where your practice will be is on the year-end review that I gave you. So this was the first page of the year-end review. I want you to flip to page 11. And I'll show you which practice I want you to do. Oh, actually, you know what? I'll give you a couple domain and range ones. So sorry, this is back on page 9. You could do the domain and range of D, G, and F. So domain and range of those guys. Circle number 2. So answer which of these from A to G would be functions. Okay, so D, F, G for domain and range. Answer which of the following are functions. For number 6, some are from 20-1 and actually 30-1. Really, the only one you could do is A. That's a 10C. Yeah, the rest are from 20-1 or 30-1. So 6A. Okay, you could do number 1. Remember, you need to be able to look at lines. Are they positive, negative, 0, or undefined? So circle number 1. Circle number 3. So this is a good one. Do B as well. Circle 4, 5, 6, and 7. And actually, let's do start number 7. So number 7, if they want slope y-intercept form, remember that's y is equal to mx plus b. I'm going to box in my y. That needs to be positive. So when you're going into y is equal to mx plus b, you decide, does that negative 2y stay or go? Edie, what would you do for that? Move it over to the right. So add 2y. And then what we would get is we would get negative 10 plus 2y. Okay, so I'm going to now box in. Now it's positive at least. So let's bring that negative 10. Let's get rid of that. Ruby, what do you want to do to get rid of the negative 10? Add 10 to both sides. And I'll have x plus 10 is equal to 2y. And then Chris from here, to get y by itself, divide by 2, divide by 2, divide by 2. Remember there's an invisible 1 here. So y is equal to 1 over 2x plus 5. So that is your slope. This is your b value, which is your y-intercept. And then you'll be able to answer these questions. Okay. For number 8, graph this guy, and that guy. So 1, 3, and 4, I want you to graph those, see if you remember. You could do number 11. '15, '16, and '17.